Yes, thank you very much for the introduction, and also for Ignacio's presentation, because he already also presented one of the main outsets, which also PortForward is working on, which is addressing small and medium-sized ports in their efforts for digitalization, to support them with digital tools based on IoT, and to help them make their operations more sustainable, make their operations more efficient, and address various issues in this respect. So, and in this presentation, I will also concentrate on one of the elements that we address in PortForward, which is the sustainable yard operations for the port of Vigo. And for that, I also built my presentation on the work of the project partners from Brunel University, Afshin Mansouri and Sian Butun, and from later Ariadna Claret. So what is PortForward? PortForward has three main objectives, or three main dimensions that we are working towards. So, and one is obviously, which I already mentioned, which also Ignacio mentioned, is smart port solutions, which means that we try to employ ICT and IoT solutions to improve information and data flows between the ports and ports communities, between different stakeholders within the ports. Also, green port solutions is one of the addresses that we use here in PortForward, trying to promote the adoption of green technologies to reduce environmental impacts and to save resources within operations. Sorry. Let me just, I don't know what's happening. No, okay. And the third one is the interconnected port solutions, to also support the combining of different modes of transport to integrate different technologies within the monitoring and control of freight flows within the ports. So also we have been around since nearly 2 years now. We started in July 2018 and will run our project until the end of next year. You can see here the different partners that are part of our project. Also, as mentioned before, we are addressing small and medium-sized ports in Europe because they are the ones which have the most challenges, as Ignacio also explained within his presentation for Pixel. And our ports are located in Spain. We have Vigo at the Atlantic coast in the Mediterranean, the port of the Baleares, especially the port of Palma de Mallorca. Then we have Livorno in Italy, Kristiansand as a partner in Norway, and the only inland port, I think, in the whole group of those projects is the port of Magdeburg. Magdeburg, the city where also my institute is located, and we are addressing challenges there. What you can also see from the consortium of the PortForward project is that the research partners, especially the research partners, they are not your typical maritime researchers. So most of the researchers and research partners within the project, they come from a more industrial, manufacturing, production-oriented background, and that is also one of the drivers of PortForward, is to see like what kind of technologies can we transfer from initiatives like Industry 4.0, digitalization in production and manufacturing, the IoT in general. What kind of technologies can we use from those experiences and transfer them into the environment of ports and support the digitalization of ports? So this is the background that we are working from. And also we try to establish a an adaptable and scalable IoT platform, which we want those ports to use. When I say adaptable and scalable, I mean that it will not be a one-size-fits-all solutions. It is a modular approach. It has a modular architecture, which builds on an IoT middleware, which basically harmonizes all the data that comes from legacy systems within the ports, sensors that are already available within the ports, but also new sensor technologies and new IoT technologies that will be brought into the IoT middleware, the IoT stack as it's called here, and then be transferred to a common cloud-based platform on which we will deploy different individual services for ports, which can be basically pick and chosen from by the ports to establish their own customized solution, basically. So we don't say like that a port needs all the services that we provide. Maybe the port will start with 1 or 2 services and then expand on 3 or 4 other services. Maybe also the port will combine different services, like in a microservice environment, and combine services to develop a much larger solution. And this is then built on the platform, which then goes into a dashboard solution, which on the one hand provides decision support, but also what is also most important for ports in this respect is a transparency of port operations. What kind of data can they use? How can they use the data? Basically establishing data-driven modes of operation. We work very closely together with our ports in this. So there's a lot of back and forth between the different use case partners and the different port operators to basically define our use cases, or not define our use cases, but carry out our use cases, because our project is a very use case driven project. All the individual services that you saw within the cloud platform basically are part of individual use cases and are developed there. You can see here the different use cases which we work on in the individual ports. We have logistics topics and maintenance topics in the port of the Balears, socioeconomic KPI logistics topics in Naples and Salerno. We use or we work on AR navigation and AR remote assistance in Livorno. In Magdeburg, we work on topics on using virtual environment, virtual representations of ports, virtual twins basically of a port to support decision making. And in Vigo, we focus on topics regarding life cycle assessment of and sustainable operations of yard operations. So, and this is also the use case that I wanted to focus a little bit deeper in this presentation. The solutions that we are working on is called the Green Yard Scheduler, pushed basically research-wise from the Brunel University in London. And the problem that we are looking at is how to best organize the yard operations in a container terminal, like with container pre-marshaling, container positioning, or also the positioning or scheduling of yard cranes. So these are the 3 elements of the operations that we are looking at, and try to figure out how can we make those more sustainable, or at least or in the beginning also to see like how can we bring sustainability factors within the calculus of actually assessing the operations in this in those yards. And we basically developed this Green Yard Scheduler. There's something missing here in the presentation, sorry. The Green Yard Scheduler, which interfaces with the terminal operating system and basically organizes and optimizes the yard crane scheduling, the pre-marshalling module, and also the container positioning module through mathematical algorithms taking into account not just efficiency of operations, but also sustainability of operations. And to basically start with assessing the sustainability of operations, we had to establish the baseline scenario for the life cycle assessment. And for that, Leitat did a very deep analysis of the individual energy uses, environmental indicators for the different categories within the yard scheduling or within the yard operations. And you can see here the different shares of how individual aspects like the fuel of the vessels, the electricity of cranes, the fuel of reach stackers, the fuel of transsteiners, and fuel of IMVs, how they contribute to different elements of the LCA, like to climate change, to land use, to water resource depletion. And you can see basically our baseline scenario that especially the fuel of the vessels in most cases nearly contribute like 50% of negative effects within the life cycle assessment. So we did this for the environmental indicators first, but in the process of the project, we also look at economic indicators and societal indicators, but they are not yet part of this analysis. And we saw that and from this LCA, we could also calculate the carbon footprint within the port per TEU, and also could identify in how far or what kind of operation has the biggest carbon footprint or share of the carbon footprint within the port, and use this then for the calculations within the green yard scheduler to do the calculations within the scenarios. And we from our first calculations and simulations, we already have some preliminary results, like that, for example, for container pre-marshalling, there could be energy savings achieved without the disruption of the operational efficiency in the terminal of 4 to 6%. For container positioning, the performance and sustainability oriented objectives, they conflict with each other. And even though we could achieve up to 34% saving in energy, this would go hand in hand with a larger inefficiency in the operation. So here trade-offs are necessary, and the same goes also for yard crane scheduling, where also we could save even up to 38% of energy, but again with greater delays in the actual operations. And this is basically how this looks in these kind of trade-off graphs, basically, that you could like reduce obviously the number of reshuffles and increase the productivity, but then you would increase the energy for container operations, or for yard cranes. It's basically the same. And here we try to bring in then also the other indicators like economic and social indicators or societal indicators to maybe provide a more extended analysis for the sustainable analysis of yard operations, and then also support the decision makers in their actual decision making on where to do those trade-offs, or provide the transparency for the overall trade-off. So that should be it for our presentation of PortForward, or for one element of PortForward. You can also follow us on our website and social media channels. And thank you very much. And I'm open for your questions.
Thank you, Christian. We will have time later for questions. Very interesting, your presentation.